Hi second graders, Miss Diorio here from Citizenship Academy, and we are moving on to Module 7, Lesson 26. This is the last lesson in Module 7, and I am super proud of you for working hard throughout this whole unit. Nice work. So today, we're going to continue drawing line plots and answering questions about them. It's important that we know how to organize our data so that we can make sense of it and we can kind of figure out trends and different pieces of information that can help us draw conclusions and give further questions and answer further questions about our data. So again, today you're going to want something to write with because we're going to be making some line plots again. So grab that, come back when you're ready. Alright, here we go. Today we're going to start with a little practice making the next 100. So what I want you to do is tell me how many we need to get to that next 100, and then we'll put it in a number sentence. So we have 170 plus blank equals 200. How many do we need? I would count by tens. 170, 180, 190, 200 is 3 tens or 30. So we're going to say 170 plus 30 equals 200. Nice job. Let's try this one. Again, counting by tens because we're going to count to the next 100. What's going to be that missing number? 110 or 10. So 190 plus. Nice job. Let's try this one. Oh, I gave you the answer to look. If we're at 160, we want to get to the next 100. 160, 170, 180, 190. 4 tens is 40. The whole number sentence would be, nice job. Oh, this one's a little bit different. We're still going to the next 100 though, so count by tens till we get to that next 100. 40, very good. Now tell me the number sentence. 260 plus 40 equals 300. Nice work. How many do we need? How many tens do we need? 3 tens are 30. What's the number sentence? Nice job. 270 plus 30 equals 300. Excellent work. Alright, we're just amping it up a little bit, but we're doing the same thing. Scoop up and count by tens till you get to the next 100. Good. 30. Tell me it in a number sentence. 370 plus 30 equals 400. Nice work. Alright, grab your paper and your pencil. We're going to try a word problem. Our application problem today says, Judy bought an MP3 player, so like an iPhone, iPod, and a set of earphones. The earphones cost $9, which is 43 less than the MP3 player. How much change should Judy get back if she gave the cashier $100? So again, this is a two-step problem. What do we need to figure out first? Do we know how much the MP3 player, the iPod cost? We don't. So that's what we need to figure out first. So our first step is to figure out how much that costs. The earphones cost $9. We know that. Awesome. The MP3 player costs $9 plus $48. And that's going to give us the total amount of money that we've spent all together. So we want to figure out how much money did we spend all together. So pause and solve for that. How much money did she spend? Good. Did she get $66? Awesome. Now step 2, she's giving the cashier $100. If she gives the cashier $100, but she only needs to pay $66, how much is she going to get back? Are we going to add or subtract to find out that difference? Good, we're going to subtract. So we're going to take that $100 that she gave the cashier, and then we're going to subtract the $66 that's the amount for her earphones and her MP3 player to figure out how much money she should get back. So pause and solve for that problem. Did you get $34? Awesome job. So our answer after all of this is Judy should get $34. There were a couple steps to this, so let's just review. So first we need to figure out how much the MP3 player cost. And that was going to be 9 plus the 48 from the $9 from the earphones plus the $43 that it was less. Then we needed to figure out the total for the earphones and the MP3 player, so we added those together and got $66. Judy gave the cashier $100, so she needed 66 less than that. 100 minus 66 gives us $34. Awesome. All right, let's get into our line plots. So, for this one, we measured the length of items in our pencil box. So it's telling us the different lengths on one side and the number of items on the other side. Remember, when you start your line plot, you're going to start by drawing a number line. You're always starting with 0. Now, do we have any items that's like 1, 2, 3, 4, 5, or 6? We have 6. So what are we going to do to mark off that we're not starting at 1? Good, those 2 slashes. Once we do those 2 slashes, we're starting with number 6, because that's our first number, and we're going to count up from there. You remember, you cannot skip any numbers. Even if they're not on, even if we don't have a measurement for it, you still need to put them on your number line. Another tidbit, another thing to remember, do not make your X's huge for one number and then tiny for the next. They all need to be the same size and lined up as best that you can so that you can best interpret your data. All right, so pause, and I want you to make a line plot for this data. Got it? All right, so we have one item that's 6 centimeters, 2 that are 7, 4 that are 8, 3 that are 9, 6 that are 10, 4 that are 11, nothing 12, 1 for 13, nothing 14, nothing 15, 3 for 16, and 2 for 17. Awesome. All right, what observations can you make about this data? I want you to pause and talk to someone at home about what some observations are that you can make. Good. So the most items are about 10 centimeters long. We don't have anything that's 12, 13, or 14, which is a little interesting. Then we have some bigger items at 16 and 17. But most of our objects are between 6 and 11 centimeters long. Did you get any of those observations? Nice. Okay, which measurement occurred the most often? Yeah, the 10 centimeters. We can see that easily from our line plot here because it's the tallest one. Again, that's why we make sure all of our X's are the same size, and we make sure that our X's are lined up so that we can see easily which one is the biggest, which one occurred the most often. What is the difference between the smallest measurement and the greatest measurement? So smallest is what? Good. Greatest is what? Good. How can we figure out the difference? Do we want to add or subtract? Very good. We want to subtract. So pause and solve. What's the difference between the smallest and the greatest? It's going to be 17 minus 6, or 11 centimeters. Nice job. Do you think that this data would look different if each student chose a different item in their pencil box to measure? I'm going to ask that again because that's a good question. Do you think the data would look different if students each chose a different item in their pencil box to measure? Why or why not? Talk to someone at home about what you think your answer is. I think it would look different. I think it might look different because what if students decided to measure like their rulers, or if they decided to measure their erasers? We might have more students down here or more students up here depending on what we chose to measure. So what we choose to measure will determine the kind of how our graph looks. If a lot of students choose smaller items, we're going to have more of a grouping down here. Larger items, it might be up here. All right. And the other important thing I want to talk to you about today is when we have a line plot that looks like this. You've probably seen a thermometer before. A thermometer is a tool that measures temperature, and we can measure temperature in degrees. Thermometers are often shown up and down. That's why this line plot is up and down. Another important thing to notice about this thermometer is that we're starting at 59 degrees here. we're not starting at like 6 or 7 or 8. We're still using the 2 slashes to show that we're skipping an amount, but we're not starting at a low amount. We're starting at 59. So I want you to try and make your line plot this way for this activity. Turn your paper sideways if you need to. I want you to try and make the line plot vertical. When you do that, you're still going to put the X's going this way. So for example, we have 1 for 59, 3 for 60, things like that. So I want you to pause and make this line plot, and then we'll talk about it. Do you make your vertical line plot? It looks like a thermometer. So I'm going to keep going with mine. We have 3 for 63, 4 for 64, 7 for 65. Whew, it's a nice warm May. 5 for 67, 4 for 68, 3 for 69, 1 for 72. That was a hot day. All right. What observations can you make about this data? Talk to someone at home. Pause and talk to someone at home. Good. So there was one really, really warm day. The most common temperature was 65. And then we have some between 69 and 63 is where the most of our common temperatures occurred in the month of May. Which temperature occurred most often? 65 degrees. Awesome job. You can see that very clearly in our line plot. Which temperatures occurred the least often? Remember, least means smallest. There's a couple that have the same amount. So which temperatures occurred the least often? Yes, we have 59 degrees with one day and 72 degrees with one day. You can see that they're on the ends of our chart, showing that these are not very common temperatures in May. Really cold, really warm. I'm going to skip that one for now. How would the line plot look different next month or in a different season? What do you think? Say we did this in June, right? How do you think this line plot would look different in June? I want you to pause and talk to someone at home. Yeah, so June is a lot warmer, so we probably wouldn't have very many X's down here, but we might go higher. We might go 72, 73, 74, 75, even maybe up to 80 and more X's up here, because as we're moving into the summer, the temperatures are going to get warmer, so there'll be less days that are in this temperature and more days up here. All right, again, for your problem set for this last lesson of Module 26, I'm going to give you a table, and you're going to turn it into a line plot, and then you're going to answer some questions about it. Have fun!